Hello, this is the edible scale presentation done by the group of Luke Dykstra, Andrew Faust, Kenneth Pate, and Asen DeBlanc. Is it possible to build an edible scale completely out of components that can be eaten? This project attempts to answer that question for the purpose of teaching us to design within constraints. The constraints being worked here are safety and cost. Since the components must be able to be eaten, they must be safe, and since we are responsible for purchasing the material, we will be concerned with the cost. This mimics real-world constraints that engineers have to work within. So the problem statement is we are a diverse group of college students from the Lone Star College system who have been tasked to come together to design, build, test, and demonstrate a functional scale made completely out of edible materials within constraints such as cost, time, and materials. Methodology was using the balancing principle. There will be a pan, the Tostita bowl, on either end of the beam. An item of unknown weight will be placed on the pan on one end. Items of a known weight will be added to the opposite pan until the beam has balanced. At this point, the known weight items, the Skittles, can be added up to calculate the weight of the unknown weight items, the pennies. Our material list was graham crackers for the structure, caramel for the bonding agent and adhesive, Tostita bowls for the item baskets, and Skittles for the counterweight. The way we constructed was to assemble the base using graham crackers and caramel, stick 2 graham crackers together using caramel as an adhesive for the beam, and use the Tostita bowls as a basket to hold the weights and measured items used. And number 4 is to use Skittles as a stand-in for grams and measure whatever desired. Our important data is our penny to Skittle ratio and measurement, the net weight of 1 pack of Skittles, and net weight of 1 roll of pennies being 61.5 and 127 grams respectively, and the number of Skittles in 1 pack versus the number of pennies in 1 roll being 58 and 50 respectively. We came out to a calculation of an average mass of a Skittle to 1.06 and average mass of a penny to 2.54. Skittles were chosen to be the counterweight due to the fact Skittles weigh on average 1.06 grams, which is within a reasonable tolerance of an actual gram. Here we have the images of the edible scale, and you can see on either image all the materials we used, plus the pennies and the Skittles, and the Tostita bowls, of course. You can also notice the assembly of the edible scale due to the construction steps that we took from the previous slide. So, our findings, which we made several of, one of the findings was the Skittles are one of the best edible 1-to-1 measurements for grams. We tested beans, M&Ms, and peanut M&Ms. None came close to Skittles. Another finding is that you can approximate the weight of pennies by using the weight of Skittles and assuming a ratio of 1 to 2.5, while the actual ratio is 1.06 to 2.54. So example, 10 pennies multiplied by 2.54 is 25.4. The actual value is about 23.95 Skittles, but due to the limitations of this project, the closest we can get is 24 Skittles. The third finding is that the material we used worked surprisingly well as construction and assembly for the project. Graham crackers and Tostita bowls are very useful. Our conclusion was the scale was a success and we were able to work within the constraints given to us by the project. The total cost did not even exceed $50 and the materials were all edible. In the future we might use something different for the bowls or maybe a more accurate material instead of Skittles, assuming there is one. All in all though, everything worked well and our findings proved usable. Now, our recommendations. The only recommendation for this project are maybe more research into materials. While what we have constructed works, the assembly is not perfect and the counterweight not exact. The tolerance is reasonable, but possibly could be better. Design works, however, and changing what was designed is not recommended. Now, we have a couple of charts and data to show. First was our trials. In trial 1, we had 3 pennies and 7 Skittles with a net mass of 7.62 and 7.42 respectively. So using a formula shown on the diagram, our percentage of error was 2.59, which is reasonable. Trial 2, we had 10 pennies and 25 Skittles. The net mass of the pennies was 25.4, with the net mass of the Skittles being 26.51. So our percentage of error being 4.36% that time. For the third trial, we had a percent error of 0.19%, with a net mass of 12.7 and 12.72 for the pennies and Skittles respectively. And in the fifth trial, we had 10 pennies and 24 Skittles, which is 25.4 grams and 25.45 grams respectively.
All right.
Just tweak the design, make it work.
There you go. If it fits, it ships.
Also, this is 24 Skittles
Yep.
with 10 pennies.
Yep.
And then we have a measurement of 24.
24 Skittles is 25.44 grams
25.4
to 25.4.
pennies. So we are really close. Really close.
As for our data, this is what we concluded as showed on the slides. Now, we also calculated out the cost for the pennies and Skittles and all of the other items that we used to construct this. So the materials we used were the Honey-Made honey graham crackers, which was about $5, and we used 17.39%. We used Great Value pure granulated sugar, 4 pounds, which was $1.58. We used about 12.5% of that. Old El Paso soft flour tortilla taco bowls, which is the Tostita bowls, was $2.99, and we used 25% of those. And the Ortega Fiesta flat taco shells was $1.49, and that was we used 16.67% of those. Skittles was $1.19. We used all of them, and then the GMO-free, at least GMO-free, we used it was $6, and we used 1.85% of those. Now, you also could argue that the material of the pennies was used, and that was just under 50 cents. We used the pennies to measure things out, so that of course comes in. Now the total cost, of course, as stated, was well below $50. It was even below 30.
When y'all are ready.
No, we're not doing
So
it.
that's the finals. Someone gonna eat it to
gonna
make sure it's all eatable.
We gotta eat each part. So first we'll start with the Skittles. You got the Skittles.
I'm gonna eat the
Okay.
Skittles.
Yeah, you need the Skittles.
Ah.
And then I'll start eating the scale itself.
All right.
Graham cracker, great. All
Take
right.
a seat. That is
Tostado. I'll eat the soft tostado bowl and you eat the hard one. We'll do it together. We can link arms. I'll eat the fish.
okay, the base.
Tostada Skittles.
All right.
in conclusion, we found that the creation of a edible scale was both a challenging yet rewarding task for us in Group 2. We found it quite enjoyable as well. We found many lessons that we will definitely use later in our careers if we continue to pursue engineering. We worked through many challenges such as communication issues due to this being a group project, which happens a lot in the engineering field. We figured out adverse constraints and we worked through those, we researched them, we found, in our opinion, the best solution to those. We came together as a group to create a product that is very cost effective at just under $3.50 when our budget was $100, and it is extremely accurate with on average about a 2% error. We came here. We also have used this experience to further our knowledge and refresh our knowledge in multiple different forms of documenting our work. This is going to be used by far the most out of anything. No matter what field you go in, you'll always have to report your research and report your findings for anything. In the engineering field, this is very important due to, depending on what field and form of engineering, this can be very groundbreaking and very elusive knowledge and material and information that are in these reports that we'll be using, and knowing how to do it effectively and being able to communicate through words on a paper rather than talking to someone effectively and fully is going to be very important further down the line. Finally, I would like to thank our teacher, Meredith Wren, for teaching us everything she has this semester. She has informed us through multiple lessons on ethics and multiple other lessons throughout the semester. It's been a very enjoyable and very informative semester in class and as a whole. She helped us through some issues that we had at the beginning of this, and we want to thank her and recognize all that she's done for this group, helping us, and we realize this is our final time to really speak with her, so we wanted to thank her a lot for everything she's done for us for this semester.